In an alternative design for the set of Christmas tree lights, a 100 ohm resistor is connected in parallel with each lamp. The arrangement that we have here is something like this. We have got the lamps, and across each lamp there is a 100 ohm resistor connected. And remember that each lamp had a resistance of 24 ohms. So that's one lamp, and then the same arrangement is done for all the other 40 lamps. And we have 40 of them. Let's put that on. Which are connected in series to each other. So in the first part, we need to describe what happens to the brightness in each set of lamps when one lamp filament burns out. For the original set, which was a series connection, when the filament of one lamp burns out, then there will not be any current flowing through the circuit, because there will be a gap in between. So no current, which means that the lamps are not lit. But if we look at the alternative arrangement, where they're in parallel with the resistors, suppose one of those lamps break, so we don't have that one, then the current will still be able to flow, but it will only have the 100 ohm resistor to pass through in that set, and then the rest will not really feel any change. So what happens is that in this parallel arrangement, the resistance is less. The current has two paths to choose to go through, and the resistance of the filament is lower than the 100 ohm. So overall, the parallel arrangement gives a lower resistance. But when this is not working anymore, the only path is through the 100 ohms, which is a higher resistance. Overall, that increases the resistance, so lamps will be less bright. Increased resistance means less current will flow through, and because the brightness depends on the current passing through, the lamps will be less bright. Then in the second part, we need to calculate the current drawn from the supply for the alternative set of lamps with all the lamps working. If we again look at the circuit that's drawn here, to find the current, we need to find the total resistance of the circuit, because we know that the current, voltage and resistance are related by, to find I, we need V over R. So we know that V is 240 volts, and if we find the resistance R, we can find the current I. But to find the resistance I, we have got parallel combinations, and then they're all connected in series. We first need to find the resistances in each of these sets. So we can call them R. And then, because those R's are in series, we will be adding those up. Because series combinations of resistance should be added up to get the total RT. And this will be the total that we want to put in there, because we're interested in the whole circuit. But how to find the parallel resistances? We need to use the resistance in parallel formula, which says that 1 over the total resistance, and by total I mean the total resistance of just the parallel section, so let's say the combined resistance, is equal to 1 over 100, which is one of the resistances, plus 1 over 24. And if we work this out, this will come to the resistance being, we can take a common denominator, so it's 2400 over 124, and the resistance will be 19.4 ohms. This 19.4 is the resistance of each of these sets, and if we add all of them up together, which means adding 40 of them, so we can say RT is 40 times 19.4, which will give us 774 ohms. And we can put that 774 into this RT there, which will give us a current of 0.31 amps.